All right, so we're moving on to question 4 of the probability FRQ packet. So this question is from 2002. This is number 2. So just Google 2012 scoring guidelines, question 2. If you want to look at it. Sorry, I had to kick my dog out. She was playing with her toys. So in this one, they gave us a spinner with different amounts of money that you could potentially win. This game costs $2 to play. Let X represent the net contribution to the charity. So how much money are you actually giving to the charity? So if it costs $2 to play and you win $0, you gave $2 to the charity. If it costs $2 to play and you win $1, you gave $1 to the charity. If you win $10, you gave -$8. So for this first part, to figure out your proportions, you just count how many times you could have won $0 over the total number of sections, and so on. My numbers match the numbers in the table. Let's see how this is scored. Oh, so section 1 is parts A and B together. So my table is good. And then I need part B to be correct as well, which is the expected count. So let's see what they got. So make sure you've shown your work like this, just like they did, and you should have gotten $0.70 or 70 cents, not 0.70 cents. So section 1, you had to have the correct probabilities in the table, and the expected count is calculated correctly with work shown. So here's my work, and then my answer, and then I also had part A. So I have 1 E so far. Part A and B, again, are scored together. They're not separate. Section 2 is part C. And part D is section 3. So in section 2, essentially correct if we have the following 2 components. We provide a solution based on a reasonable calculation equation or inequality from the given part in B. And you clearly selected the next highest. Bleh. So we want to make sure 0.70. So I wrote 500 equals n times 0.70, which is the same, or they did greater than or equal to, which is fine. And you got 714.286, but we're talking about the actual number of games. So we have to round that up. That's different from an expected number of games, because we want it to be at least 500. So I have to go up to make it at least 500. If I go down, it's going to be below 500. So if you have a reasonable calculation like I do here, and then you also have, you've also clearly rounded up. So if you only have component 1 but not component 2, that's a partially correct. For section 3, you need the following components. Indicate the use of a normal distribution with the correct mean and standard deviation. It's right here. Uses the correct boundary and indicates the correct direction. That's what this does. And this is a newer scoring guideline from the question we looked at earlier. So this is what they typically look like now. They ask for the correct mean and standard deviation with the correct distribution like that, the correct boundary, and then the correct answer. Let me just confirm that is the correct answer. Yes, 0.9844. So you can see that they do it the long way here, but this has all three components. This should be the minimum amount of work you need to get full credit. If you have two of the three components, that's a partially correct. And the correct probability just has to be consistent with part 1 and 2. So if you made a mistake on part 1 or 2, but then you had an answer consistent with that, you could still get a partially correct. So this was an E, this was an E, and that was an E. So this question is 4 out of 4. All three E's is a 4 out of 4. 2 E's and a P, 3 out of 4, etc., etc. Same drill as usual.